Let's go ahead and get started on this very clickbaity title that drew a pretty big crowd. Is Spark still relevant? How many of you are hoping that I'm going to say no? Just a quick show of hands. All right. So, and yes? Why are the rest of you here? No, it's fine. About me, I am currently a solutions architect at Anaconda. That means that I talk to most of our large customers about kind of problems that they're having in this space, how our enterprise product can, fit inside of their infrastructure, which is usually enterprise. How many here have done anything in the enterprise involving like IT and InfoSec and ticketing systems and yeah, okay. So some people here are fully aware of that pain. So, we try and help our customers navigate through that minefield. I'm also part of the CondaForge core team. Before that, I worked in ad tech on a Hadoop platform team. That was, a fun job, but, it's ad tech, so it's got its downsides. Before that, I wrote scientific software at Brookhaven. Before that, I finished a PhD in chemistry, which is not at all relevant for anything that I do today. So should you go to grad school? The answer is probably not. Just keep that in mind. So my original talk plan was to do a bake-off between Dask, Spark, and Rapids. We have this great downloads data set internally at Anaconda with billions of rows. Basically compare Dask, Spark, and Rapids through kind of an end-to-end life cycle of, the kinds of problems that we solve in this space. That was a little ambitious. I didn't really think through how much infrastructure I was going to need to actually do a proper bake-off. So about a week ago, after I had spent about a week and a half fighting with Parquet formats, I'm like, I'm going to pivot this talk. So we're not actually doing that. This would be great to do at some point. It would also be great as a blog post. So hopefully I'll have some time and space to get that done. I also came to the realization that I'm not really going to move the needle with like an N+1 talk on why Dask is functionally equivalent to Spark, or like why Dask is better or faster, or why Rapids is, orders of magnitude faster than both of those because GPUs. There are tons of those out there already. Feel free to laugh at me about, how ambitious that was. So this talk instead is Spark still relevant? The answer is yes. So for those of you that wanted me to dump on Spark, you are welcome to leave. I will not be offended. That is not what this talk is. So instead, I'm going to try and answer the question of why our enterprise is still choosing Spark, right? Many of us here know Dask or Rapids or this ecosystem and really wish that we could use it in our day-to-day jobs instead of Spark. But for reasons that hopefully will become clear throughout this talk, we're going to look at why that's not the case right now. So what is this about? A brief overview, what do businesses care about, right? These are kind of my experiences from talking to our Anaconda enterprise customers, from talking with other people in this space as well. I'm going to do hopefully a reasonably thorough job of comparing these different ecosystems in terms of different functionalities. Also, please feel free to come find me, and I will, happily give you this talk deck. So if you're taking pictures, please feel free. But we'll figure out a way to get you the talk slides. So comparing the ecosystems across a number of metrics, kind of just an example, PowerPoint version of what an implementation would look like. And then kind of some thoughts at the end about how to actually drive adoption into the enterprises of these technologies. So first off, who here knows what Spark is? All right, Dask and Rapids. Okay, so real quick, because that wasn't everybody in the room, Spark, you have distributed data frames on the JVM on the CPU. Dask, you have distributed data frames on the CPU in Python, and Rapids is distributed data frames in Python on the GPU. In very short, there are many. So I know that Tom is here on the Dask team. I know that Keith is here from Rapids. So if you want, more info about that, then I would talk to them. So what do businesses care about? Risk. That's kind of it. That's like the big thing that businesses are going to be focused on. And everything else in this talk really kind of centers around risk and managing it and minimizing it and understanding it and quantifying it. Kind of different ways that you can think about risk. You've got the notion of time to value, right? Which is how fast am I going to start seeing this affect my bottom line, right? How much is this solution going to cost me to own, right? And you can get answers to that with Spark pretty easily. There's an ocean of people that you can go to for help here. I think there's one company that you can go to with this for Dask, and that's Quansight, and they're brand new, right? Like there's not, like if you look at this ecosystem, there's not as much available in the Dask space to service these kinds of enterprise needs, and certainly not in Rapids because they're brand new. But I mean, they're doing a fantastic job, but they're still brand new, right? I mean, it's not like this is anything unique to Dask. This is just what happens with a brand new project. SLAs and support, right? Who are you going to call at 9 p.m. on a Tuesday when your infrastructure falls over, right? You're not going to go post to the Dask issue tracker and say, help. Well, I mean, you probably are now because you can't go pay anybody for this. Same thing with the support, right? Who are you going to go when when Dask is almost the right choice, but you need a new feature, right? You're not, I don't know. Well, Quansight, right? But like there is not an ocean of these consultancies like there is with Spark. And if you are in that space, please come talk to me because it would be very useful for us at Anaconda to have a stable of these kinds of companies and people that we can talk to and work with to help our clients do better. Sales pitch done. All right, so some examples of like custom solutions that you would want to implement, right? Like you've got Dask and Rapids. How do I bring that into my existing infrastructure, right? How do I hook it into my existing auth, right? So talking to some people here, they've told me about their horrible homegrown auth systems, right? And these are not, small companies. These are Fortune 50 companies that have, for whatever reason, decided to write their own auth, right? That's not going to plug in easily. So, you would need to pay somebody for help with that. Connecting to a database, connecting to your specific type of networked file storage. How do I push a Dask job into production with my enterprise scheduler? Like these are things that businesses care about. And they will happily pay people to build out custom pipelines for data engineering or machine learning. Finally, training, right? Who are you going to pay to get these people up to speed, right? So, those of us that are in this room are already on that path of, becoming experts on Dask and Rapids, but there are a lot of people in the enterprise that are not in this room right now. And, maybe each of you will go back and train the people around you, but realistically, to make a dent in the Spark adoption inside of the enterprise, you need people that can go and train. So just in summary, those 5 things, we will see this slide again. I'm not going to read a slide to you because that's awful. Okay, so ecosystems. So this is where we're going to look at these different products in terms of these different ecosystems in terms of metrics that I thought were relevant. So first off, we've got the maturity of the project. So this one's pretty straightforward. Apache Spark has been around, I think, what am I going to say? Yeah, so Spark is about 9.5. So it's been around for a while. I think Dask is approaching its 5th birthday. Rapids, I thought it was a couple years old. Keith today told me it was a little over a year, so somewhere in the 1 to 2 years. So the syntax here, checks are like, yeah, cool, okay. The yellow warning sign is like, you should dig into this a little bit. You'll see a red X on the next slide. That's like definitely like warning here. So job scheduling. So if you've got jobs that have to run, if you want to submit jobs to production, how do those work? Spark has the Yarn for all of its flaws and for all of the people that hate Yarn, it still does a pretty darn good job of getting things done in a constrained system. So if you've got an on-prem cluster and you've got limited compute capacity there, right? Like you're going to have more people trying to use it than you have capacity for, and Yarn does a good job there. Rapids, I think this, after some conversations, this shouldn't be a red X because Rapids in many ways will fall back on whatever Dask can do. So the Dask ecosystem will be dependent on its backend. So if you run Dask on Yarn, then it's the same story as Spark. If you run Dask on Kubernetes, and again, please, come up to me afterwards and tell me that I'm an idiot because, there's this obvious thing that I should be aware of. But from my understanding, Kubernetes doesn't have the same type of kind of queuing mechanisms that Yarn does. And you've got the different HPC backends, so Slurm and PBS, that I am completely unfamiliar with, but they're there as well. So also to keep in mind the difference between on-prem and cloud, right? So if you're on the cloud, then none of this really matters, right? The metric is how much you're going to spend, not like how much you've already got in place. So the notion of kind of queuing in the cloud is far less relevant because you just spin up your elastic Kubernetes cluster and you don't have a queue, but it might cost a lot. So you've got workflow scheduling, right? So Spark, you've got Uzi and Azkaban. I think Azkaban was out of LinkedIn, is that right? Maybe? Anyways. With Rapids and Dask, you've got tools like Airflow and Luigi. I think, so show of hands, who knows what Airflow is? Okay, cool. Luigi? Prefect.io? Much less. Okay, so Prefect.io is a company in this space that will sell you. So they have a product that's Airflow plus Dask. It's an interesting option and does help kind of my narrative here around like growing this ecosystem is going to require more companies in this space that are trying to support these products, that are seeing the enterprise problems, that are building tools in the open source space that will help drive more adoption. So, I mean, realistically, there's good options on both sides here. So with scalability, single node versus distributed, right? With Spark, so does anybody here actually use Spark in local mode? Okay, I really want to talk to you about why. Not like because I think you're doing anything wrong. I'm just curious because I don't run across people that frequently that use Spark in local mode. So maybe that was a bit unnecessarily harsh on technically yes, but I have no problem being wrong about any of this. So with Rapids, you've got single node performance. That's amazing because you're on the GPU, and we've all heard how GPU makes everything a lot faster. And Dask has a great single node story. It's very easy to use. It gives you the APIs that you're used to. Distributed mode, Spark versus Dask. That's a fairly straightforward story. And Rapids distributed. The only reason that's kind of like yes-ish is because I don't think that they've got the full kind of stable of distributed algorithms that things like Dask and Spark do yet. But again, I could also be very wrong about that. Also, I don't know how common distributed GPU clusters are yet. So it's not to say that you can't build one, and it's not to say that NVIDIA won't happily sell you one. But I just don't know, kind of in terms of finding people that you could pay to manage it. I think that would also be hard. All right, so algorithm-wise, right? We've got kind of graph algorithms, machine learning, and deep learning. Again, there are good choices for everything here. The only reason why the machine learning side with Spark here is yellow. I don't know how many people would voluntarily pick MLlib over scikit-learn. I think that my kind of completely unscientific poll of people that I've talked to in this space would much prefer the scikit-learn API and kind of the rich ecosystem of algorithms that scikit-learn will provide over MLlib. Spark does have XGBoost, right? But you also have XGBoost available in Dask, and I think there's a CUDA accelerated version of that as well. Admittedly, I don't know the deep learning story on Spark. So if there is a very good, very compelling deep learning story there, great. Come talk to me again. Tell me why I'm an idiot up here. I'm totally fine with that. Yeah, data visualization. This is where this is really the spot that I think Spark is missing a big chunk of the ecosystem. I mean, I don't. Again. I don't think that there's a rich ecosystem like there is in the Python world for visualizing with Spark. I mean, maybe Databricks has a product that would be fantastic for this. I just don't know. I haven't encountered anybody who does work in Spark and then knows how to visualize their 100 million or billion row data frame. I personally know how to do that in Rapids and Dask. You can use Data Shader and Dask to spin this up, and it works great. You can build an interactive dashboard that can serve 100 million rows of data, and can downsample it in real time with you can zoom in and zoom out and change filters and all that. It's quite nice. In terms of a data frame API, right? They've all got this. The biggest hole in the Dask ecosystem right now is the lack of SQL, right? There's no SQL compiler in Dask. And Rapids there's a product in the Rapids space called Blazing SQL that gives you this type of an interface. So why do we care about SQL, right? I mean, it's, 2019? So according to Stack Overflow, professional developers still use SQL far more than they would use Python. I also like to take a little jab at R and Scala here, but that's fine. That's fine. But seriously, so SQL is where the kind of people that we would label as less technical, right? The business analysts, the marketing scientists, but those are the people that actually know how the business is run. They are incredibly valuable. Without those people, you're going to have a much less effective business. And generally speaking, many of them are quite comfortable in SQL. So things like Spark SQL, things like Blazing SQL, give your marketing science team, your business analysts, access to your petabytes of data that are locked away. I think that's a big gap in the Dask ecosystem currently. Regarding data access, right? With Spark, you've got access to HDFS, S3, Hive, flat files, et cetera. Python's got a much richer data access story. You can access everything that you can with Spark. It's probably not as performant, but it doesn't have to be. So streaming-wise, again, this is not necessarily so much as which of these streaming libraries is better. It's more just that they're all there. This is a comparison of ecosystem functionality more so than it is a bake-off between Dask plus streams is so much better than Spark streaming, or that's not what this is. The capability is there. And also this is, again, I have not spent enough time in the streaming world. So this is a real dense slide, but this is effectively a summary of everything that I just said, and I will have this slide up at the very end for questions as well, so this is not the last time that you have an opportunity to take a picture of this slide. But the important takeaway here is the trends, right? For the most part, they all have functionality across this slice of the ecosystem, right? There's not one perfect tool here. You could almost certainly use any of these independently in terms of their technical feasibility, right? In very specific circumstances, maybe you want more than one of them in the long term. Again, the biggest holes here are the Spark ecosystem, I think, is lacking a little in the kind of machine learning, deep learning, visualization space compared to the Python space. And of course, the big red X on Dask is a proper SQL engine. All right, so time check, we're at 18 minutes. Okay, cool. So, real quick, let's start talking about some of the architecture, some of the infrastructure, the ways that you would actually start to stand up some of these things. We'll grow in complexity. We're going to start with Rapids, right? This is a very easy to understand slide. You go buy a server from NVIDIA, and you can use Rapids. It's very easy. You've got the Python interfaces to your data. You certainly can do shared infrastructure and have multiple users on a single GPU. This is not in any way saying this is the perfect architecture. I don't work at NVIDIA. I have no idea if this is the perfect way to get this up and running. But in terms of like ease of use, in terms of minimizing the infrastructure costs here, you probably just want to give data scientists their own server just for starts. Then people can work by themselves and get off to the races. A really good way to run Dask right now is Dask on Kubernetes. It's very simple. We've Anaconda this year has been working on a project called Dask Gateway. Happy to talk more about that later, or if there's time at the end, I can certainly come back to it. But basically, the idea here is that if you have Kubernetes already, or if you want to run on the cloud, you can spin up Dask Gateway. You Helm install it. You can Helm install it into an auto-scaling Kubernetes cluster. It works with whatever auth you have in place already. Users will connect to Dask Gateway. Dask Gateway will spin up a Dask cluster on Kubernetes. Dask Gateway will proxy the scheduler back to the user, and it'll proxy the Dask dashboard as well. So you can have everything behind a Kubernetes zone, and then still so you would run the Dask client locally to wherever these users are. And you've got full access to whatever data you have. And also worth mentioning is that the Rapids project can also, or the Rapids ecosystem will also work. Well, it will work the same way eventually. We need to add support in Dask Gateway to run Dask CUDA workers, but the infrastructure would theoretically be the same here. Spark on Yarn is a much harder diagram to actually like put up on a screen. There's a lot there. But in terms of getting, being useful and getting work done, right, you can either SSH into an edge node and run Spark Shell or PySpark, or install, a Jupyter notebook and port forward that. I know that you three there in the second row that I worked with at MaxPoint have all done this. So you can use something called Livy, which is a server that you run on the edge node. It exposes interactive Spark over HTTP. You can use a project in the Jupyter ecosystem called Spark Magic to connect to Livy and run interactive Spark from wherever, right? You've got the SQL interface with Hive and Spark SQL. You've got scripting with Pig, Hadoop, Yarn, Spark. Okay, so kind of with that out of the way, how do we start getting PyData? How do we start getting Dask and Rapids into the enterprise? Like, how do we penetrate that space and get it to the level of prominence that Spark has? I happened to find this really good quote from Hussein when I was doing a bit of research for this talk, and I really like it because it's basically the same point that I'm trying to make, but it's not from me. So clearly at least one other person has the same thought here. So I will read it because it's interesting. It's hard to get organizational buy-in to adopt an open source technology without vendor support and enterprise SLAs. So how many people in this room have fought this same battle? One, two, a handful, probably 10, 20. And I, talking to a customer about 4 months ago, they said this to me, and I didn't really know what to say because I was taken aback, right? Like, they're not all in on Dask because what if Anaconda isn't around in a few years? And I was like, but there's more to it than Anaconda, right? Like, there's NVIDIA's contributing. There are folks, well, those are the two big ones, and Quantside as well. And there's a horde of kind of smaller individual contributors, but like it definitely plays to the same point of like, who are they supposed to call for help? Who are they supposed to pay for implementation services? Like, how is this supposed to work at the enterprise scale? So I thought it was relevant enough here. So again, as promised, a reminder of my thesis here. These are the things that enterprises are going to care about. These are the things that enterprises do care about. Looking around for phones up. All right, I will. Oh, I got you. All right, so, right, we're not missing features, right? This isn't a lack of features in Dask, right? Think about Jupyter Hub, right? I mean, it's not like Jupyter Hub isn't. I mean, Jupyter Hub is everywhere, but it's not seeing more adoption because it lacks features, right? what we need to see Jupyter Hub, dominate the landscape are consultancies around it, are people that are solving these enterprise problems around these open source projects. So here's another really fun, controversial slide that I'm sure I'll get a lot of flack for. I'm totally fine with that. The whole point here is to spark a conversation. Right, for all of these, right, Spark is green across the board, well, blue across the board. Right, I don't really even know how you would quantify the risk of adopting Rapids or adopting Dask inside of your enterprise infrastructure. I don't know, right? I mean, I think that there's a real big need in this space for people to really stand up and proclaim, like, I'm an expert in Dask, like, pay me and I will help you figure out how to adopt Dask inside of your enterprise. In terms of institutional support, right, Dask has at least 3 companies behind it right now. We've got Anaconda and Quansight and NVIDIA. In terms of institutional support for Rapids, I think that's pretty much NVIDIA at this point. Again, come tell me that I'm wrong there, right? But in terms of the risk, right, if you only have one company behind this open source ecosystem that you're building your business on, if they decide that they don't want to, build Rapids anymore, then you're, risk, right? Same story with consulting and implementation services. I don't know of anybody right now that you could go and pay for support and implementation in the Rapids ecosystem. But again, I don't know that I would expect it either, because they're like 1 to 2 years old. For Dask, again, I know of Quansight. I don't know of anybody else. Again, if you are that person, come and talk to me. Training-wise, I know that you can get training support for Dask, and I'm just ignoring Spark because you can get these things from an ocean of consultancies, or Cloudera, or Databricks, or EMR, or there's a lot of ways in which you can get that. Training services, I'm pretty sure you could go to Quansight to get training on Rapids. Yeah?
Yes.
Okay. Thank you, Anthony. And then kind of the same thing with risk. I don't really know how to quantify the time to value and total cost of ownership for tools like Dask and Rapids. Let me take a quick look at my presenter notes. Yeah, okay. All right, so what do we do? Well, for starters, you could build a proper SQL engine, a proper SQL compiler in Dask. That'll help you onboard more job titles to the Dask ecosystem. That gets you the business analyst, the marketing scientist, business intelligence, et cetera. The people that, again, actually know how your business works. You can start a product company in this space to productize something around Dask or Rapids. That'll reach more enterprises. You could start a consulting company around Dask or Rapids, although it's probably a little early for Rapids. That'll help to make it sticky in these enterprises that want to use Dask but need help. So for those of you in the enterprise, right, for the actual practitioners here, like, what can you do with these ecosystems? How should you think about using them and adopting them? So the first question is, do you already have Spark, right? And if you have Spark, great. Like, you have a tool that you can use. If you want to use Dask, Dask Gateway works with Spark, right? There's a number of projects in the Dask ecosystem that are specifically designed to work with Spark on Yarn. There's Dask Yarn, there's Dask Gateway that you can install alongside your Hadoop cluster, where Dask Gateway will then talk to Yarn and provision Yarn containers and run Dask workers inside of those Yarn containers. So you get to use Dask without needing any new adoption of any new infrastructure. And if you don't have Spark already, then you should probably think long and hard about adopting it. It's a very complex stack. Question 2, do you have Kubernetes? If you do, great. Helm install Dask Gateway. You'll probably need to work with your IT teams and your InfoSec teams, but at least you don't need to try and argue that you need new infrastructure. Do you have GPUs? Again, if you do, awesome, right? You can conda install Dask or Rapids and just start playing around with it and figure out if it solves the use case. And if it does, then you've got some more ammo to go say, look, we need to invest more in this. It solves these kinds of problems. Then the obvious question is, do you have cloud access? And if you do, great. You can use Dask on an auto-scaling Kubernetes cluster. You can try Rapids on some GPU instances. Very low risk here. But you still are ultimately going to need to make the case about why you should be adopting Dask, why you should be adopting Rapids, and it's not going to be the easiest thing in the world. Again, because you can't go pay somebody to help you make that argument, right? There's no support, or I mean, there's open source support, but you can't. The enterprise need for support isn't there. Okay, cool. So, in summary, right? We've got, Dask and Rapids are basically at ecosystem feature parity with Spark. The reasons why Dask and Rapids are not seeing the same adoption as Spark is not due to features. We need companies in this space. And you can also start using these today. So came in a lot under what I thought I was going to. So thank you for listening. As promised. All right, so unfortunately I have time for questions in this very controversial topic. So here we go.
Hey, I thought it was a great talk.
Nice.
Just a question. How much do you think the adoption of Spark was driven by offerings by the major cloud providers? I mean, Amazon picked it up in like 2015, and that's like, what, 4 years after it was released by Berkeley? Would that mean that like Dask and Rapids would be at least like 4 years out before you would see major cloud adoption?
Well, I mean, so that's a good question. I don't have a good answer for you. I think that Dask is kind of approaching that spot where we can start to expect to see. Oh, good, Anthony, great. Where we can start to see some cloud companies start some like Dask as a service type companies. In fact, Hugo has one. Hugo's goal here is to be Databricks for Dask, as I will say, but you should talk to him because it's
accurate.
Okay, well there you go. Yeah, so Databricks for Dask right here. So I would expect these to start to show up for Dask certainly. And like honestly, I think the cloud landscape of 2015 is very different from the cloud landscape of 2019. So we'll see. All right, what you got, Anthony?
All right. Hi, Eric. So it occurs to me that you're overloading the term ecosystem here to mean both corporate ecosystem and community ecosystem. And those, it seems like those. The point of this talk is to try to resolve some of those discrepancies and maybe help bring an open source ecosystem into to be able to serve the needs of these corporate ecosystems. Are there resources available that help like inform and educate us all about how that happens and help resolve those two ecosystems?
That's a very good question. Which I suspect is why you had it. I don't know. I mean, it takes people that are bridging that gap, that are both involved in open source but are also in the enterprise and kind of trying to drive these kinds of problems and solve these kinds of problems. It sounds like a great opportunity to write some interesting blog posts, but in terms of broader resources and tools, open to ideas. Thanks.
Well, we have time for one more question.
All right. Cool. Well, thanks everybody.
All right. Thank you. Thank you, Eric.